All right, welcome to chapter 2. Before we get going, this hopefully isn't a problem. I'm outside at night. It's a nice summer night. You can hear crickets chirping, but there's a bright light shining behind me, and I hope you can see okay. But we'll just do the best that we can. This first section is about if-then statements and their converses. This is really about definitions and understanding these statements, because they are going to show up all the time, all year long here. So let's be able to talk about them intelligently and answer questions about them intelligently. An if-then statement, also called a conditional statement or a conditional. These are simply statements that are based on conditions, which makes sense. If something happens, then something else can happen. An if statement is called a hypothesis. The letter we use for this is P. The then part of a conditional is called a conclusion. The letter we'll use for that is Q. If you're wondering where the P and the Q comes from, we borrow that here in geometry from a world of math called logic, which I took a logic class once. It didn't make a lot of sense, but anyway. We talk in conditionals all the time. We say, if this, then that. If you go this, then I'll do that. We talk like that all the time. So pause right now. Well, pause after I say this. Give one example that may happen to you today or tomorrow. If this, then. Go. All right, here's mine. If I hit a hole in one, then I will be happy. You bet I would. The part of that's the hypothesis is the if part. If what? I hit a hole in one. That's the hypothesis. The conclusion is the then part. Then what? I will be happy. Hypothesis, I hit a hole in one. Conclusion, I will be happy. Now, symbolically, we could say if P, then Q, where P is the hypothesis and then Q is the conclusion. Some other forms of the conditional statements would be using the word implies. P implies Q. I hit a hole in one implies I will be happy. It's kind of a weird way of saying it. We don't really talk that way. Another way is only if. I hit a hole in one only if I will be happy. That one doesn't make sense for me here in this case, but and we also don't really use the only if statement talking very much. We do this one though. Q if P. I will be happy if I hit a hole in one. Oh yeah, I would be like, you'd hear all about it. So yes, those three things. The only time the conclusion happens before the hypothesis is if it says only the word if. Notice it doesn't say then in that case. Okay, so it's not always an if-then statement. Sometimes these if-then statements or conditionals will have the conclusion first. So one thing we'll be doing is identifying hypotheses and conclusions here. So example one, underline the hypothesis once and the conclusion twice. Okay, if it rains, then the game will be canceled. It is totally easy if it uses the word if and then. If it rains is the hypothesis, then the game will be canceled. The game will be canceled is the conclusion. Okay, it's less obvious if it uses the word if. So be careful here. It says angle A is acute if the measure of angle A equals 60 degrees. They should have put the word or the degree symbol. That's frustrating. Anyway, so if it uses the word if here, the measure angle equals 60 degrees is the hypothesis, and then angle A is acute is the conclusion. Okay? So if it uses just the word if, then the conclusion usually will come first. So, and then these four examples just simply identify the hypothesis and conclusion like I just did in those examples. Pause the video. So that's one simple type of question that we'll be doing here. Here's some answers. Hopefully you compared well. All right, the next definition we need to talk about is called a converse. A converse of a conditional is formed by interchanging or switching the hypothesis and the conclusion, which may end up creating a true statement or a false statement. Because it's true or false doesn't really matter. So in the example that you gave for your if-then statement, write it as a converse. Do that. Pause so you can do it, and then do it. Is your statement still true? It either is or it isn't, of course. Look at mine. If I am happy, then I will hit a hole-in-one. Is that true? I don't think so. Holy smokes, I wish it was, because I'm usually happy when I'm playing golf, and I rarely hit hole-in-ones, but still. One other piece of this. If an if-then statement is false, then a counter-example is the example where the hypothesis is true and the conclusion is false. Okay, this is simpler than that sounds. Okay, actually I just had a huge interruption with my daughters. Let me back up here. If an if-then statement is false, then a counterexample is the example where the hypothesis is true but the conclusion is false. Okay, plenty of times an if-then statement is not right. Like if I say, if Tennessee plays against Vanderbilt in football, then Tennessee will win. Well, no, that's not true. Evidenced last year, 2012. Thank you very much. So that's a false hypothesis. So a counterexample for that is the thing that says, if the hypothesis is true, if Tennessee plays Vanderbilt in football, that's a true thing. It happened last year. But the conclusion is false. Then Tennessee will win. Well, no. They lost. Bad, actually. Okay? It only takes one to disprove the statement. It's not a fact that happens. Okay? Y'all do this with your friends all the time. And what do you don't usually say, well, I have a counterexample. No. You use this language. You say, nuh-uh. I call these nuh-uh statements. Counterexamples are like nuh-uh statements. If somebody says, if this, then that, and you can go, nuh-uh, and you can give something that disproves it, where the first part of it is true, the hypothesis is true, but then the conclusion is false. Well, then you've proved it wrong. Okay? So I'll do this first one with you. In this set of examples. Tell whether each statement is true or false. Then write the converse and tell whether it is true or false. If the statement of the converse is false, give a counterexample. Okay, the statement. If two angles are right angles, then they are congruent. Is that true? Well, yeah, they're both equal to 90 degrees. Yes, that's true. So, then write the converse. All right, if two angles are congruent, then they are right angles. That's the converse. Is that true? Well, no. So that's the converse. There's an example of two acute angles that are congruent. So no, that's not true. So that's all that you're doing here. Number 6 says x is greater than 7 implies. Remember, turn your page back over if you want to remember how implies works with the hypothesis and the conclusion. But try 6, 7, 8 right here. Go. Pause. So 6, 7, 8, there are my answer. You may have had a different counter example on number 6. I said false, 4. If the converse was if x is greater than 2, then x is greater than 7. Well, no, that's not true. 4 is greater than 2, but not greater than 7. All right, so we've talked about if-then statements with a hypothesis and conclusion. We've now talked about converse, which is where you interchange those hypothesis and conclusion. We've talked about the counterexample where you can disprove a statement, a conditional statement. And here's the last term, a biconditional. Bi means two, conditional, of course, so it's a two conditional statement. It's a statement that contains the words if and only if. This phrase can be used when a conditional and its converse are both true. Okay, so when you flip it around and it's both true, you can say if and only if. It goes both ways. Okay, so example 4 here says, write the biconditional as two conditionals that are converses. Let this be simple. Here's the conditional statement. Line K is a bisector of segment XY if and only if line K intersects segment XY at its midpoint. It sounds like a bunch of words in one there, but we learned that to be true. So we can say it this way. If line K is a bisector of segment XY, then line K intersects segment XY at its midpoint, which we learned that to be true when we learned midpoint. To say it the other way around, if we switch those hypothesis and conclusion of that statement, if line K intersects segment XY at its midpoint, then line K is a bisector of segment XY. When we talked about bisectors and midpoints, we said that that is true because it's true both ways. That's called a biconditional. All right, 9, 10, 11 just ask you simply to do what we just did. Write the statement twice as it's two conditionals and that are converses of each other. That's all you got to do that's left. All right, that's the end of section 2.1. Gosh, get some rest. We've been busy lately. Talk to you soon.